Welcome to the video for 2.4 Moles in Solutions. You will need to look at textbook pages 33 to 34 to help with this video. The lesson objectives for today are to calculate concentrations and volumes for reactions in solutions. This will be limited to titrations of monoprotic acids and bases, and any example where you've been given the equation. Monoprotic sounds complicated, but all it means is an acid that will donate one proton. So for example HCl, it only has one H because it's H, whereas sulfuric acid, for example, has H2SO4, so it's got two hydrogens, so that would be diprotic. So we don't need to worry about examples like sulfuric acid and phosphoric acid in this video. First of all, some basic information. So a solution is a solute dissolved in a solvent. You should remember this from GCSE. So the solute is what dissolves, which is normally a solid, and the solvent is what does the dissolving, so that's normally a liquid. And the concentration of a solution is a measure of how much solute there is in a given volume of solution. The units of concentration are moles per decimeter cubed, so that decimeter minus 3 just means per decimeter cubed, and 1 mole per decimeter cubed means that there's therefore, if you've got 1 decimeter cubed of solution, there will be 1 mole of solute. You've met this concept at GCSE, so you should be familiar with it. But at GCSE we talked about it in grams per decimeter cubed rather than moles per decimeter cubed. So here are the all-important equations that you need to learn. You not only do you need to learn them, but you also need to learn how to rearrange them. If you can't rearrange equations very easily, then you have two options. You can either practice them until you can rearrange them, or you just have to learn the different forms of them. So this first equation here is linking concentration with the number of moles and the volume. So the concentration, which we represent with a capital letter M, is equal to the number of moles divided by the volume in decimeters cubed. Now this is the bit that people quite often mess up in exam questions, that they don't convert the units from centimeters cubed to decimeters cubed. So if you're using this equation, concentration equals number of moles divided by volume, then you need to remember to convert it from centimeters cubed to decimeters cubed. We'll also be using this equation here, which is number of moles represented by N equals mass in grams divided by molar mass in grams. You've already met this before, so you should be familiar with it. I've just put it here to remind you because we are going to need it today. This final equation at the bottom here is just a different form of the first one that we have here. Okay, so in this one, the number of moles in solution N equals M, which is concentration, times V divided by 1000. This is just the first equation rearranged with a slight difference, and many students prefer to remember this one at the bottom because it means you haven't got to mess around converting centimeters cubed to decimeters cubed, because in this last one the volume is already in centimeters cubed. So number of moles in solution is equal to M times V divided by 1000. So it's just a different form of the first one. Now there are a different way of representing these formula, which is with these magic triangles here. You should have met these sort of triangles at GCSE, but I'll just refresh how to use them in case you've forgotten. So we'll start with this first one here, which shows the relationship between moles, volume and molarity. So if you wanted to work out the molarity, for example, I'm just going to put this arrow over it to block it. So if we wanted to work out the molarity, you cover up in the triangle the molarity, and it then becomes the other two. The relationship between the other two is then shown by where they are on the triangle. So in this case we have moles here, and then we have a horizontal line, so that means divide by. So to find out the molarity, it's the moles divided by the volume. If we wanted to work out the moles, we'd cover up the moles, and then because there's a vertical line between the volume and the molarity, that becomes times. So the number of moles would then be volume times by molarity. And then lastly, if we wanted the volume, it would be the moles divided by the molarity, because they're separated by a horizontal line. So if we go into the second triangle, which represents mass, number of moles and molar mass of atoms, If we cover up the mass, it becomes number of moles times bimolar mass. If we cover up the number of moles, it's mass divided by molar mass. And if we want to work out the molar mass, it's mass divided by number of moles. You have met this magic triangle before, but it's worth going over it as we're using it in a different way. So the most important thing you can do is probably to do some practice calculations. So we're going to start off with a very simple calculation, and we're going to use the equation that's here. The concentration M is number of moles divided by the volume in decimeters cubed. So in this question it's asking what is the concentration of a solution that contains 0.25 moles in 500 centimeters cubed. So the first thing we need to do is we notice that the volume is in centimeters cubed and we need to get it in decimeters cubed. So to convert the volume into decimeters cubed, we have to remember that 1 decimeters cubed is equal to 1000 centimeters cubed. So to go from decimeters cubed to centimeters cubed, you would times by 1000. So going the other way, if you got centimeters cubed to go to decimeters cubed, you need to divide by 1000. So in this case, 500 divided by 1000 is 0.5. So our volume is now 0.5 decimeters cubed, which means we can now simply plug the figures into the equation. M is number of moles, which is 0.25, divided by 0.5, which is the volume we just worked out, and that will give us 0.5 moles per decimeters cubed. So our concentration of the solution is 0.5 moles per decimeters cubed. Now there is an alternative way of doing this calculation, which is to remember, if you remember the slide with the 3 equations on, there is a different form on the bottom, where number of moles in the solution, N, is M times V divided by 1000, and in this case the V is in centimeters cubed. So this is a simpler way of doing it, because we haven't got to convert our volumes, so there's less chance we're going to make a mistake. So all you have to do is rearrange that equation to find out the molarity, because that's the concentration we're trying to work out. So if you rearrange that equation, you get M equals 1000 N divided by V. So that just simply becomes 1000 times 0.25, because the question tells us that we've got 0.25 moles. Divide that by 500, and that gives us 0.5 moles per decimeter cubed, which of course is the same as we got using the previous method, because you should get the same answer to the question regardless of which of these 2 methods you use. It doesn't matter which of these 2 methods you use, as long as you stick with one and practice it so that you're familiar with it and you don't make mistakes. So you need to be familiar with more complicated calculations, which are normally based around titrations. Now in titrations, which you may have done at GCSE, and in your practical lessons you've probably done some already, there will be a solution whose concentration is unknown, and you titrate that against a solution whose concentration you do know. And the idea is that by doing this we can work out the number of moles and therefore the concentration of the unknown. So in this more complicated calculation example, it says 28.3 centimeters cubed of a 0.1 mole per decimeter cubed solution of sodium hydroxide was required to react with 25 centimeters cubed of a solution of HCl. What was the concentration of the HCl solution? So we're trying to work out the concentration of the HCl solution, and we've been told what the concentration and the volume of the sodium hydroxide was. Now it's important to practice these calculations, because despite being quite simple, students do make mistakes with these time and time again, and it's usually because they get mixed up between the volumes. So they use the wrong volume, so they use the HCl one when they should be using sodium hydroxide, or vice versa. So it's important to take these stepwise so we don't make mistakes. So the first thing you've got to do is write out the equation, and you should know that HCl plus sodium hydroxide, that would be the equation, because you end up with sodium chloride and water, because of course acid plus base gives salt plus water. So this is the simplest example you'll get, because you've got HCl and sodium hydroxide. There's 1 mole of HCl reacts with 1 mole of sodium hydroxide. So first of all we work out the number of moles of sodium hydroxide, and we use this equation that we've got, number of moles N equals M times V divided by 1000. So all we have to do is plug our figures in. If we look in the question, then it tells us that the molarity of the sodium hydroxide is 0.1 and the volume is 28.3. So we just times 0.1 times 28.3 and divide that whole thing by 1000. It's important to do this properly in your calculator. Quite often students will make a mistake in their calculator at this point because they will, for example, put 0.1 times by 28.3 divide by 1000 into your calculator, and that won't work. You have to press equals, because otherwise you're just dividing the 28.3 by 1000, not the whole thing, so you have to be careful with that. So that gives us 2.8 times 10 to the minus 3. So that's how many moles of sodium hydroxide there are. So now we know how many moles of sodium hydroxide we are, and if we look in that equation, it tells us that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So the number of moles of hydrochloric acid has got to be exactly the same as the number of moles of sodium hydroxide. So if we have 2.8 times 10 to the minus 3 moles of sodium hydroxide, we also have 2.8 times 10 to the minus 3 moles of hydrochloric acid. So we now know the number of moles of hydrochloric acid. And because we know the number of moles, and we know the volume, which is in the question, which tells us it's 25, we can now work out the concentration of the HCl. So we have to rearrange this equation that's at the top. So concentration, which we represent by M, of course, is 1000 times by N divided by V. Now N we know because we just worked it out as 2.8 times 10 to the minus 3, and V is in the question as 25. So it then becomes 1000 times by 2.8 times 10 to the minus 3, and then divide the whole thing by 25. And that gives us 0.112 moles per decimeters cubed. So we've now been able to work out the concentration. You need to practice again and again these sorts of calculations, either from examples in the textbook, or that you've been given in your homework, or ones that you can find online. The more you do of these to practice, the better you will be at them. These should be second nature by the time you come to your exam. So we just review our lesson objective, which was to calculate concentrations and volumes for reactions in solutions, and limited to titrations of monoprotic acids and bases, and examples where you've been given the equation. So just go back over your notes that you've made, and if necessary use a textbook to make sure that you fully understand and can do this lesson objective.